Assalamu alaikum. Today my topic is the mole and molar calculations. So first of all, let's define what is the mole. One mole, it can be defined as any element or compound which contains Avogadro number of particles, that is 6.02 into 10 raised to power 23, that is called 1 mole. I repeat that 1 mole of any substance contains Avogadro number of particles. It can be an element, it can be a compound. For instance, hydrogen. So hydrogen, it is the smallest element, and if we are considering hydrogen atoms, so the atomic mass here, AR stands for relative atomic mass and MR stands for relative molecular mass. For example, now hydrogen, its atomic mass is 1, the hydrogen atom. So if we take 1 gram of hydrogen, so that will be 1 mole of hydrogen, and that will contain 6.02 into 10 raised to power 23 number of hydrogen atoms. This is the concept of mole, and this is the concept of Avogadro number. Avogadro was the Italian scientist who gave this concept. Similarly, let's take another example. Oxygen. Oxygen, its atomic mass is 16 if we are considering oxygen atom. So the atomic mass of hydrogen of oxygen is 16. If we take 16 grams of oxygen, so that will be considered 1 mole of oxygen, and it will also contain 6.02 into 10 raised to power 23 number of oxygen atoms. It's a very huge number, very large number, having 23 zeros along with it. Now similarly, if we are taking the example of iron, so iron, its chemical symbol is Fe, its relative atomic mass is 56. If we take 56 grams of iron, so that will be considered 1 mole of iron, and that will again contain 6.02 into 10 raised to power 23 Avogadro number of iron atoms. And now let's take the example of water molecules, which is a compound. Here all these examples were of element, but now I am giving the example of a compound, for example water, or it can be any other compound. It can be methane, CH4, it can be ammonia, NH3, it can be copper sulfate, CuSO4, or any ionic compound, sodium chloride or calcium carbonate, or any compound. So remember, if we will, for example water, here I am taking the example of water, H2O. The formula of water is H2O, where hydrogen, its atomic mass is 1. We are multiplied it by 2 because here in the formula we are having 2 hydrogen atoms, plus oxygen atomic mass is 16. So 2 ones are 2, 2 plus 16 is equal to 18. It means that the molecular mass, relative molecular mass MR of water is 18, and if we take 18 grams of water, so that will be 1 mole of water, and that will be 1 mole of water, and that will 18 grams of water will definitely it must contain 6.02 into 10 raised to power 23 number of water molecules. Or it also applies for ionic compounds, it also applies for ions. So how, now the question is that how is it possible that 1 gram of hydrogen, which seems smaller value, and 16 grams of oxygen, both of them are containing 6.02 into 10 raised to power 23 hydrogen atoms in this case, and in this case 6.02 into 10 raised to power 23 oxygen atoms. Why all of them are containing this constant number of atoms or molecules or ions? The reason is, the argument behind it and the logic behind this is that hydrogen is a smaller atom. Rather, it is the simplest atom and the smallest atom in this case, I should say. So, while on the other hand, oxygen is 16 times heavier and 16 times larger than hydrogen. So that's why its mass will be larger, its mass will be heavier, but the number of atoms will be same. Similarly, for example, if we are taking carbon, so atomic mass of carbon is 12 and the atomic mass of copper is 64. So if we take 12 grams of carbon on one hand, and on other hand if we are taking 64 grams of copper, so both of them will be containing equal number of atoms. Here 12 gram of carbon will be containing Avogadro number of particles 6.02 into 10 raised to power 23, and on the other hand copper 64 grams of copper, it will be also containing 6.02 into 10 raised to power 23 copper atoms. Why? Because of why the difference of the mass is there? The difference is because of the size of the atoms, the relative size of the atoms. That's why the difference is there in their masses. But the number of atoms, the number of ions, the number of molecules are always same. This is a constant value and it has been internationally proved. It is Avogadro number, Avogadro constant. So this is the concept of 1 mole. I can also explain it with the help of fruits. For instance, like cherry is a smaller fruit. So here we can see that cherry is very smaller fruit, and maybe that the average mass of one cherry fruit is 10 grams. And apple as compared to cherry is a bigger fruit, and the average mass of one apple is 100 grams. And as compared to apple, mango is here, this mango is a bigger fruit, and suppose that this one mango fruit is having mass of 200 grams. So if I take 1 dozen or 12 cherries, so they will be containing, suppose 120, they will be having 120 grams. This one dozen of cherries will be having 120 grams of mass. And if I am taking the example of if I am taking 12 apples, so with the while mass of each apple is 100 grams, so the total mass of 12 apples is 1200 grams. Or if I am taking the example of mangoes, if I take 12 mangoes, so they will be containing 2400 grams. 12 mangoes, their collective mass will be 2400 grams. The mass is different. Here in this case 120 grams. Here the mass of the apple is 1200 grams. Here the mass of the mangoes is 2400 grams. But the number of fruits are 12 and 12. 12 cherries, 12 mangoes, 12 apples, 12 mangoes. So similarly we can apply it here. Why the difference of the mass is there? Because of the different size of the fruits. Therefore the mass of each fruit or the mass of 12 number of cherries is different. The mass of 12 apples is different. The mass of 12 mangoes is different. But the number of fruits in each case is 12, 12 and 12, like in 1 dozen. So here Avogadro number is like 1 dozen. The relative atomic masses or the relative molecular masses of each element or compound is different according to their size. But the number of atoms or molecules or ions, number of particles are constant. So this is the concept of mole. Now let's study and try to understand the important formulas for solving molar calculations and for sorting out the molar questions. First formula is number of moles is equal to mass upon molar mass, or mass divided by molar mass. So this formula is applied when the mass of the substance is given in grams. For example, if it is given in grams, or for example if it is given in kilogram, you can convert it into grams by multiplying it by 1000, but it is for mostly it is for solid substances. For example, the mass of copper oxide is given that it is 120 grams, for instance, so you will write it here, and the molar mass of copper oxide will be written here. That's a fixed value, and that will be derived from its formula. The formula of the calcium carbonate or copper oxide or copper carbonate or water or whatever, or it is element or compound, so you will write it here. Second formula, it applies for gases. Number of moles is equal to volume divided by molar gas volume. This formula applies for solving the questions which are for gases. For instance, the gas is oxygen gas or hydrogen or methane or ammonia or carbon dioxide or sulfur dioxide, any gas at room temperature and pressure. For instance, the volume of you can say of hydrogen gas, if it is given that it is 12 cubic decimeter, it is a unit, cubic decimeter. So, and the molar gas volume of all the gases, either it is any gas at room temperature and pressure, that is molar gas volume is a fixed amount, that is 24 cubic decimeter. That's a fixed value. Molar gas volume of all the gases at room temperature and pressure. It means that any gas, if you will take 1 mole of oxygen gas, so that will contain 24 cubic decimeter of volume. If you will take 1 mole of hydrogen gas, that will be containing 24 cubic decimeter of volume. If you will take 1 mole of sulfur dioxide gas, that will also contain 24 cubic decimeter of sulfur dioxide. So this is a constant value. So here you will apply, for example, if we are taking 12 cubic decimeter, so the molar gas volume is 24, so the answer will be 0.5 moles. This will be the number of moles. So this formula applies for gases, or here this formula applies for the substances which are if their mass is mostly taken in grams in solid form. Third formula applies for solutions, for aqueous solutions. For example, aqueous solution of sodium chloride. For example, aqueous solution, aqueous means dissolved in water. For example, aqueous solution of copper sulfate, or it can be acids or alkalis, sulfuric acid, nitric acid, or alkalis like sodium hydroxide, potassium hydroxide, etc. So all these are in aqueous form. So there, for solving these questions, for solving the questions where there are aqueous solutions, so we will use formula number 3, and the formula number 3 is number of moles is equal to concentration multiplied by volume divided by 1000. And why it is divided by 1000? Because mostly the volume of any solution is taken in small amount, in centimeter. For instance, it can be 100 cubic centimeter, 200 cubic centimeter, 500 cubic centimeter. So by so volume, we are not taking it in decimeter. Decimeter is a large value. It is in 1 cubic decimeter is equal to 1 liter. So we and in 1 cubic decimeter, there are 1000 cubic centimeter. So if we are converting the centimeter into decimeter, so we will divide. If we are converting the centimeter into decimeter, we will divide it by 1000. And if we are converting the decimeter into centimeter, we will multiply it by 1000. So here we are dividing it by 1000 because centimeter is a smaller value. So we will divide it by 1000 to convert it into decimeter. Why we are converting it into decimeter? Because here the concentration is mentioned, is given in decimeter. So both units should be same. Therefore we can apply them. We can apply the both values if they are having the same unit in this formula, and we will multiply them. Then the answer will be correct. And the fourth formula is MV, where M stands for molarity. M stands for molarity. It is the same thing. It is for concentration, and it's molarity. And its unit is also its unit is moles per cubic decimeter. Moles per cubic decimeter. So if we are using, like for instance, 1 mole, if we are taking 1 mole of sodium chloride and we are making a solution of 1 liter, up to 1 liter, up to 1 cubic decimeter, so that's molarity will be 1 cubic decimeter. If we are dissolving 2 moles, if we take 2 moles of sodium chloride in 1 liter of solution, so that will be, it means that its molarity will be 2. Its concentration will be twice. Molarity or concentration is same thing. Mostly this formula is applied for solving acid, alkalis or neutralization reaction questions. So here molarity, M stands for molarity, V for volume and N for number of moles of an acid, for instance. And here on the other side of the equation, it is the molarity and volume and number of moles of an alkali. For instance, let's take the example of this particular reaction. Sulfuric acid and sodium hydroxide are reacting. They are neutralizing. This is a neutralization reaction, and they are neutralizing. They are reacting to form a salt, sodium sulfate and water. So let me balance this equation, as here there is 1 sodium and on the right hand side there are 2 sodium. So I will write 2 here to balance the equation. So now here there are 2 sodium and there is 1 sulfate, there are 2 hydrogen, and here on the right hand side there are 2 hydrogen, but on the left hand side there are 2 plus 2, 4 hydrogen. So I will write here 2. So in this way, now it means that there is 1 mole of sulfuric acid which is reacting with 2 moles of sodium hydroxide to form 1 mole of sodium sulfate and 2 moles of water. So here, while we are solving the question, so what will be the value of N in this particular case of sulfuric acid of this reaction? It will be 1. And what will be the value of alkali, and what will be the value of N here? In this case it will be 2. And the volume and the molarity maybe for acid is given, and molarity for alkali the molarity can be asked or volume can be asked. So if we have 4 values, MV, MV, MV of acid and MV of alkali, out of these 4 values, if 3 values are given, so we can find out the 4th value with the help of this formula. So all the molar calculations can be solved by these 4 formulas. So that's how we can solve the molar calculations.